Okay, so today we're gonna film a lab for you guys today, and we are gonna look at the pH scale. So I wanna point out a couple of things here about the pH scale, and then I'm gonna actually be testing different solutions with some indicators. And an indicator is gonna change color in a different solution to tell you if it's an acid or a base. So the pH scale, if you have a pool or if you've ever had to test it, you know, hopefully, that water is exactly neutral. That's gonna be at 7, and anything below 7 is an acid on the pH scale, and anything above 7 is a base on the pH scale. So that's kind of what we're testing today, acids and bases compared to for the pH scale. So these are our different indicators here for the lab. We're gonna be testing blue litmus paper, which looks like this, sorry. So we're gonna test blue litmus paper in these 10 solutions, and I'll show you those in just a second. We're also gonna test red litmus paper in just a minute, and then we're gonna do pH paper, which is gonna give us a specific number for the pH. When it turns a color, we're gonna match the color and write down what the pH is, and then we're gonna test something called cabbage juice indicator. So it's like this purpley looking solution, and it is made from cabbage, and it is neutral when it's purple, so that's neutral for the cabbage, and then it's gonna turn different colors in acids and bases. Typically, it'll be pinkish in an acid and more like a darker blue in a base. There's gonna be some colors in between, and that's okay. We'll just write down the color that it turns on the lab sheet over here, but you're gonna kind of see how this is gonna work, okay? So I wanna walk over this way, and we're gonna start with our vinegar solution. So on the lab we have here, we're gonna start with our solution number 1. This is gonna be vinegar. Okay, and I'm gonna be testing it with blue litmus paper and red litmus paper, and then we're gonna write down what colors they change. So if they stay the same, we're just gonna write it stayed the same and was red if it was already red litmus. If it changes though, we're gonna write what it changes to. So this is my red litmus in the vinegar, and this is what it looks like. So it looks to me like it stayed red. So I'm gonna write on my lab sheet for that one, for red litmus paper and solution number 1, I'm gonna write that it is red. It stayed red. Okay, now I'm gonna test it with the blue. So same thing, I'm just dipping it in. Immediately turned red. So the blue litmus paper turned red. Okay, so we're gonna write red. It is red in blue litmus paper. Okay, so that was our vinegar solution. Now we're gonna do the pH paper. So I'm gonna grab a piece of this, and then we're gonna compare what it looks like. Okay, so I'm gonna drop it in. Oh, that's like immediate. So let's see if we can figure out which color it matches best. I would say somewhere between maybe like a 2 and a 3. I think it's a little bit too red for the ones. So I'm gonna say something like 2.5. Okay, if you think it's 2.6 or 2.7 or 3, that's fine. I'm not gonna count off for that. But you're just matching the color. And you can see the original paper color was orange, but it definitely turned red immediately whenever I put it there. So I'm gonna say somewhere in between a 2 and a 3, maybe like a 2.5 is what I'm gonna write for that. And your number, the number is not what I'm super worried about. You just need to be within a range, okay? Now the cabbage juice, I'm gonna take a few drops, and I'm gonna add that, and it should turn color. Remember, the neutral cabbage patch. The neutral cabbage indicator is purple, so it's either going to change probably pinkish or bluish if it is a base. Okay, so I'm gonna add a few drops. I'm gonna swirl it around. Okay, so zoom in on that. You can see that it is definitely a pink color, so I'm gonna write pink on the cabbage juice indicator for the vinegar. So make sure you're filling this in with me. This is exactly what we are doing for the lab today. Okay, so ammonia, I'm gonna do the same thing. I'm gonna start in the same order. That's our number 2 solution. I'm gonna start with, I'll start in order. I'll do blue litmus, then red, then pH. So blue litmus, I'm gonna say that probably stayed blue. So I'm gonna write it's blue. The red litmus, like sort of. I'm gonna give it a second. You can kind of see that it's starting to turn blue as it sits there. It's not like blue. I don't want you to think it's the same color as the Post-it, but it definitely is more blue than it is red when it was before. I know it's kind of hard to see, but I promise in person it's starting to turn blue. So we're gonna say that that turned blue as well. Okay, and then we're gonna do the pH paper, and then I wanna compare these two and then talk about what that means for the pH scale. So pH paper, grab a piece of that. Wow, immediate color change there. Okay, so if we look here, let's see if we can match it. So if I try to match it like I did before and have it be between 1 and 2 or 2 and 3, it's nowhere near that color. It's more of a bluish green. So I would say it's more like in between 9 and 10. Okay, so the pH I'm gonna say is about 9.5 for this one. And then I wanna talk about the scale for just a second before we test the cabbage. So down here we have our pH scale, which I mentioned at the beginning. So remember, from 0 to 6 is an acid, from 8 to 14 is a base, and 7 is exactly neutral. So if we look at our first two, our vinegar, we said was around 2.5 according to the pH paper. So if it's at 2.5, that's down here in the acid range. So I would say that vinegar is an acid. And guess what? It is. It's acetic acid. Okay? And then ammonia, we said, had a pH of 9.5 according to that pH paper. And that is over here on the base side. So ammonia is a base, and that is a cleaner, which makes sense. Okay? So that's kind of what you're looking at today. I want you to understand what we're doing. So let's try the cabbage juice. Add a couple of drops to the ammonia. I need to add a little bit more. Okay? So that is more of like a greenish color, which is fine. We're gonna write green, but remember the one we just did was vinegar and it turned pink, and we said that was an acid. So it makes sense that this is like a greenish blue. Okay, so I'm gonna write green. If you wanna write blue, that's fine, but to me it looks more green here in person. All right, so now we're gonna test coffee. If you wanna take a second and guess what you think might happen, you are more than welcome to do that, but I'm gonna do the same kind of order before. So I'm gonna start with blue litmus paper. I really wanna do the other end so I don't waste it. So our coffee and blue litmus paper at the top is like a pinkish color. So very, very slightly pink, okay? So I'm gonna say pink instead of red because it's not really red in my opinion. And then our red litmus paper and the coffee. No color change, stayed red. So far that should tell you that it is an acid just based on the litmus paper. If something is red on litmus paper, it's gonna be an acid. If you notice our first one, which was very clearly an acid, they were both red. Our second one was very clearly a base, they both turned blue. Okay, so this one, the pink and the red, pretty much we kind of know it's an acid, so we know the pH should be less than 7. So let's test it with the paper and see what the color changes to. So this is our coffee. And then I'm gonna compare. Still kind of looks like the pH paper, so not a super acid down here. More in the orange range, maybe between like 4 and 5. Still an acid. Remember, anything below 7 is an acid. So I'm gonna say about 4.5. And because it's an acid, what color do you think our cabbage should turn? Hopefully it turns the pink color like the vinegar. We'll have to see. The coffee might be a little bit dark to see it though. You may not be able to see it. Mix it up a little bit. It's a little bit red. It's just hard to tell on the film. Yeah, it is a little bit red. It's definitely not blue, that's for sure. So I'm gonna say it's not really pink though. I would say maybe like a dark red. So still red, still means we're gonna be talking about the acid. The pH tells me that it's an acid. It's just not quite as strong of an acid. The lower the pH, the stronger the acid, typically. Not 100% of the time, but typically. So it's just not as strong of an acid as vinegar is. The lower the pH, the stronger the acid. For bases, the higher the pH, the stronger the base. Okay, let's try Sprite. So we're gonna do blue litmus first. This is our Sprite. Oh, that immediately turned pink. So that is definitely pink. So write that down, and then our red litmus. Stayed red, or pink, whatever you want to call it. Our pH paper. Our Sprite. Okay, so we have our color change. See if we can match it. It's not really a 1 or a 2. It's a little bit more orange than that. So I would say maybe between, it's a little bit, I think maybe it's almost exactly a 3. I would say it's probably right at a 3. Okay, remember if the pH is below 7, it's an acid. So you can just write 3. You don't have to write a decimal every single time. And then we're going to test our cabbage. So Sprite. Definitely a pinkish color that you can see. Definitely a pinkish color. So that's probably a little bit of a stronger acid there. Okay, so I'm going to say pink. So the cabbage juice and the litmus sort of just tells us if it's an acid or a base in general, but the pH is going to give us a more exact number along the scale. So that's kind of the whole point. So these indicators do tell you if it's an acid or a base, but it doesn't give you tons of information. You really need to do pH paper or use a pH meter to give you a digital readout in order to determine the exact pH from the scale. All right, drain cleaner is next. So we're going to start with blue litmus paper. It's like sticky. So that is definitely blue. So we're going to say that is blue. Our drain cleaner is blue in the blue litmus. So that should immediately tell you it's probably some kind of base. Our red litmus paper and our drain cleaner turned pretty blue. It's kind of like a grayish blue, but it's blue. So that's blue as well. And then our pH paper. And the drain cleaner. Oh, that was like, the pH paper is so immediate. It's crazy. All right, so if we compare it, it's nowhere near any of the acids. It's like a bluish green color. So it has to be something on this end. I would say it's probably right around a 9 or so. Maybe in between an 8 and a 9, like an 8.5. And if the pH is above 7, that makes it a base. So that makes sense. The cabbage juice, let's try that. Add a couple of drops of that. It's not dissolving very well. There we go. That turned more like a green color. Oh, that's yellow. Okay, so we're gonna write yellow. Definitely not red at all. So that tells me that the reddish pinks are the acids. So anything that is green or yellow is looking like it's going to be a base. Okay, baking soda is next. This is baking soda in water. Okay, and we're going to do the blue litmus first. Stayed blue. The red litmus in baking soda. I really want to make sure it gets on there. I would say it's really no change. I don't really see any blue. I mean, maybe a little bit, like a tiny bit, the longer I sit. I'm gonna let it sit for a minute. It looks like it's starting to change. It's just really slow. The baking soda also may not have been dissolved as well. That is, I mean, that's a little bit blue. When I compare it over here, I would say that's a little bit blue compared to the red, the original red color. Just a tiny bit though. It's not, I'm going to say blue-ish because it's not really blue. All right, the pH paper. Of course, it's stuck. So baking soda. Ooh, nice green color. I would say that is right about an 8. So very, very slightly above 7, which means, there's a glare. That's pretty much exactly an 8, which means that it is a base slightly. So I'm going to say exactly an 8. And the cabbage should be like maybe a green or a yellow since we know it's a base according to the pH. We'll see. It might be blue. Surprise. Yeah, so it's like a bluish green, which is good because we said the ammonia was a base and that's a pretty green. So when you compare those two, definitely like on the blue-green scale. I'm gonna write blue-green. You write whatever color you think you see. Okay, let's do milk next. Very slightly, well, that's kind of white. Very slightly pink on the blue litmus paper. Very slightly pink. And then our red litmus paper. Stayed red. I would say that stayed red. So that's, I'm gonna say pink because it's not really very dark or bright. Our pH, we know since they're both pink or red, it should be some kind of acid, so it should be below 7. Let's see what color it changes. So not quite as dark as a 1, 2, 3, maybe like a 6. Very, very, very slightly. It's pretty much exactly a 6. There's a weird glare. There we go. Very, very slightly acidic. It's really, really close to 7, which is neutral, which is good because we drink it. So I'm going to say 6 on that. And then our cabbage juice. Let's see. I'm going to swirl that around a little bit. Did nothing. There's just not enough. It may not have enough in it to change color. It's starting to get a little bit pink, I think. Yeah, there it is. Very, very, very slight pink. Very slight. Very light pink. Still means it's an acid. It's just a very, very weak acid because it's really, really close to neutral, which is 7. All right, our soap. Do blue litmus first. I'm gonna reuse some of this. It's gross. Stayed blue. Our red litmus. Oh, it's so goopy. Give it a minute. Starting to change. You can see a little bit how it's starting to turn slightly blue when I hold it next to these two right here. Very, very slight. Like you see those little tiny blue spots. It just needs some time. It's just not quite as immediate. But it's very, very slightly blue. Very slightly blue. Okay, and then our pH paper. Barely changed. I would say it's pretty much right at a 7. So that's why it's barely changing. It's pretty neutral. And that makes sense because what do you use soap for? For your hands. And so if it's going on your hands with water, it can't hurt you. So I'm gonna say it's right at 7. And then our cabbage juice hopefully stays maybe purple. We'll see. Mix that up a little bit. Top of that is definitely purple. It's not very soluble in the soap. Yeah, I'm gonna say that stayed purple. So it is pretty neutral. Our soap was pretty neutral, which makes sense because we use that to wash our hands and we want things, I don't have soap on me, we want things to stay neutral if we're gonna be putting it on our hands. All right, so lemon juice, we're gonna do blue litmus first. We're almost there, guys. I know this is a long video. That was pretty immediate red. Our red litmus. Stayed red. Our pH. That is really fast turn of color. So that is definitely more on the red side. I would say maybe between like a 1 and a 2, like a 1.5. So that's going to be a very, very, very strong acid. Which makes sense because acids taste sour and lemon juice is super, super, super sour. Remember, anything less than 7 is an acid, anything above 7 is a base. So that should mean that our cabbage turns a pink or a red color. Pretty immediate. Lemon juice is a pretty strong acid. Very pink. All right, one last one, guys. So our blue litmus. This is toilet bowl cleaner. Actually turned a little bit more blue, if you can imagine that. That's pretty blue. Our red litmus turned blue immediately. That's a bright blue as well. So that should be telling you that is a base. Anything that turns blue is a base. So our pH should be above 7. We'll see. hopefully. Yep, really, really dark blue here immediately. So notice all of my acids and stuff are red and orange, so I'm nowhere near that. So it's gonna be probably like a 10 or 11, maybe like a 10.5. You can see as it drips down, it's turning all of it blue. It is a very, very strong base. So I'm gonna say 10.5 on that one. Pretty high. And then our cabbage, our last little indicator, should be a blue or a green color. Make sure I mix that up a little bit. Yeah, there it is. That's definitely green. So for the cabbage, it seems like most of the ones that were bases turned like a greenish or a yellow color. And the darker the green, the more basic it was, or the higher the pH. And then all of the acids turned like a pink or a red color. So that was kind of it. And then our soap stayed pretty neutral, which is why it stayed purple, which is my favorite color. So now you should be able to answer the questions on your sheet.